In this video, we are going to talk about duration when it comes to bonds duration. It's a straightforward process, and it's about measuring the sensitivity of the bond to changes in interest rates. The data that you will be provided for this calculation is the settlement date, that's your starting point, maturity date, which is your end point. You have a coupon rate, the coupon rate of the bond in question, 8% in this case. Yield to maturity, the yield to maturity now would be 10%. That's the part that could change, which would then have an impact on the price of the bond. And that is what we're looking for when we do duration calculations. How much would it impact the bond based on changes on interest rate, the yield to maturity. Coupons per year, we're going to keep it simple, just one per year. Now, I'm going to first start with the Excel functions for these calculations, just so you can see the values that you get, and then we'll go through the manual calculation, which you will see then that they match. Excel has a function, as you can see, is duration and some values. The settlement date, that's here. Your maturity date, that's here. Your coupon rate, that's there. The yield to maturity, that's there. And the frequency, how many times per year, and that's there. And that's how you get that 2.774. Then we have the modified duration. Same inputs. Settlement, maturity, coupon, yield, and frequency. And you get the 2.5249. Okay, so that's how you would use Excel functions with those pieces of information. Now, in the slides and the textbook, you're going to see these formulas for yield, for duration and the change in bond price, and then the modified duration that you use the duration value to get the modified. But first, we will need to know what that D value is in order before we can get the change in bond price on changes of yield to maturity. So that's what we're going to go over here. This, it's a formula to find that value here, that D value there. Because once you have that, then you can also do the modified duration very easily to eventually get the change in bond price, which is what you're looking for. So let's go over this. This is the key formula you want to use to calculate duration. So we're going to start by breaking down some of these numbers and getting the values that we need. So first thing I'm going to do is I'm going to set up this 3-year timeline. The reason is because from the settlement date to the maturity date, we have 3 years. Then I'm going to go ahead and record the coupons for each one of those years. That's a fairly straightforward calculation. Notice that I take the coupon rate, 8%, and I multiply by 1,000. Now, the reason for 1,000 is when you are not given the face value or the par value of the bond, we will assume $1,000. So unless it's specified a different face value or par value, the assumption would be $1,000. And then we take that number, that coupon, divided by the coupons per year. Now, because the coupons per year, it's only one, you get the entire 8% one time at the end of the year. If the coupons were quarterly, every 3 months, then you'll have a 4 there, and that will be divided by 4 for your quarterly coupon. And that pretty much repeats itself throughout the 3 years. The yield to maturity, we take the yield to maturity, we divide it by the coupons per year. So if there would have been quarterly, then we need the yield to maturity per quarter. But in this case, divided by 1. For this calculation, we assume the yield to maturity stays steady throughout the 3 years in order to get the duration number that we need. Now, once we have these numbers, this setup, so we can get the data that we need, we just took the All we did was convert the coupon rate to a dollar amount and a payment per period. And we just went ahead and recorded the yield to maturity to make our next calculation a little easier. Now we're going to start in the formula. This top piece, we're going to start with the entire top portion of the formula, and we'll do the current bond price at the end. However, to understand this top piece, this sum of only applies to this piece here, not this piece. If they need it, if mathematically, the mathematical formula, if we wanted to do all this first and then add it together, there would have been a parenthesis here, a big one to cover all of them. But no, there's not, meaning we have to address this first. And after we address the sum of this, then we add that at the end. So let's work through this piece first then. So you notice here, T times C, that's our top part there. So that is our coupon multiplied by the time, the period. And then we do this. Coupon times the period. And then we do that as well. What this is doing like a cumulative coupon payments. Now, the bottom part of that formula, that's just a discount rate, like you have done many times before in finance. It's 1 plus some rate at some t. So it's discounting them. In this case, it's discounting them using the yield to maturity. So 1 plus the rate, elevated to the periods, in this case 1. And that's how we're doing here as well. So that's really just doing a discount rate. Okay, so now we have the two values that we need for this piece. Now we're actually going to do the division. This right here is what you're seeing as the whole piece. We took care of this, took care of this. Now we're dividing each other by it. So you can get that piece there. So the 80 divided by the 1.1 to do the proper discounting. And then we do the same there. And the same here. Now that we have those three values, now we can go into the sum part. We're going to add them all together. Remember, we're only adding these values. We will do this later. So all we're doing is sum of these three values. Now that's the number that I need for this piece. I have taken care of that. Let's talk about this here. So this is also just discounting some kind of value. So we can go ahead and put it all together in one place. So here we have ND7, meaning the periods. This is a 3-period exercise. So N in this case means the periods, the total periods, 3, times M, the maturity value. The maturity value in this case will be also the face value, par value. Once again, if it's not specified, we will use $1,000 as the standard number we assume when that's not specified. So in this case, the M is our face value. Then we divide it using the discount rate approach. 1 plus the yield to maturity, that's all that Y there, elevated to the 3 periods. So we're discounting the whole thing because we're using the maturity value, which is the end of 3 years, or 3 years in this case, and then discounting all the way to present value. That gives us that number that goes here. So now we just got to take care of this plus sign in the middle, this plus that. So now we add those two together and we finally have the number that goes at the top. $2,639.22 is the number that goes here on the top of this formula. So all we need to know is find the current bond price so we can then divide it. So current bond price is just present value. This is the Excel way to do it. I strongly suggest you practice this in your financial calculator, but all you're doing is getting the present value of a bond using the time value money functions. So you want to practice this on your calculator. So rate, periods, payment, future value, We get the present value of it. You should get 950 and 26. Once again, practice it in your financial calculator. You could use the manual formula for present value when payments are involved, but it's just a little longer to do time-wise, and it's more prone to errors. Once we have that bottom number, the present value of the bond, now we can go ahead and divide them and we get the duration. And that's all we do now. So divide those two and you have finished your formula. The number's the same here, so you're good. If you don't get the same number, Excel is typically right to make sure you still input the right values for the Excel one. And if you get the same numbers here through the manual process, you have done it correctly. Then we can use this formula here to get the modified duration, which is the duration divided by 1 plus the yield to maturity. So you only need discounting by one period in this case. And once you have those values, you can calculate the change in price, the rate of the change in price for the bond. And that's how you get duration. And that's how you can do it manually through the function or through the function in Excel. That's it for this video. See you on the next one.